Hello, and welcome to the third International Conference on Software Engineering and Machine Learning. I am Ella Haig, an Associate Professor in Artificial Intelligence at the University of Portsmouth in the UK. Today, I will talk about modeling human characteristics with artificial intelligence, and in particular, I will focus on modeling polarity and emotions. I will start with why we might want to model subjective phenomena, give a brief overview of what we mean by polarity and emotions, and then present some case studies from my own research. I will then focus on some of the limitations and challenges in modeling subjective phenomena with AI. So why model subjective phenomena? We humans have always looked to understand ourselves and the world we find ourselves in. We know that despite a high capacity for reasoning, we make choices that seem irrational. Due to advances in psychology, sociology, and economics, we know that our decisions are biased, both in individual and collective contexts. So we want to better understand ourselves to support better decision-making, both individually and collectively. In some contexts, currently it seems that our understanding of ourselves, and in particular our biases, are used against us, as in political campaigning and advertising. But it can also be used to create better regulations and laws, and to develop better social environments and support systems, and also prevent negative outcomes both at individual level and at society level. The term sentiment analysis is most often used when we talk about modeling polarity. Polarity is looking to capture subjectivity in terms of a positive or a negative opinion. Sometimes a neutral category is also included, which would indicate objectivity. Emotion detection is more recent than polarity detection and a more difficult problem, requiring AI models to distinguish between several distinct emotions. Several theoretical models about emotions are being used, of which Ekman's list of 6 universal emotions is the most well-known. There are also models or lists of emotions specific to particular contexts. For example, in the context of learning, emotions such as boredom and confusion are more relevant than the generic emotions from Ekman's model. I will now present several case studies of modeling polarity and emotions from my own research. The first case study is about learners' polarity and emotions collected from students' feedback with the aim to extract actionable information to improve learning and to also improve the student experience. We also looked at sarcasm in this particular context, which is a specific special problem that we need to be aware of. Now, this work is from around 10 years ago, and I will contrast this with the next 2 case studies, which are more recent. So for polarity detection, we worked with 1,036 tweets, and these were labeled as positive, negative, or neutral by 3 human annotators. You can see the distribution on the slide. The best performance was obtained with an SVM classifier and had very good results with metrics close to the maximum value of 1. For emotion detection, we worked with 1,522 tweets and 8 learning-related emotions that you can see listed on the slide. The results show that the performance is much lower than for polarity detection, which is in fact expected given that emotion detection is a much more difficult problem. The best performance we obtained was for the detection of boredom. Now, this work was done before the introduction of transformers and large language models. As we will see later on, these new technologies improved emotion detection to some degree, but this still remains a difficult problem with performance nowhere near close to polarity detection. I will now focus on sarcasm, in which one says or writes the opposite of what they mean. It is a form of irony that conveys criticism in an indirect way. So why do we want to detect sarcasm? Essentially, because if we don't, the meaning is lost. So with our current AI tools, the opposite meaning will be inferred. As you can see from the slide, we obtained disappointing results. These, however, are in line with the state-of-the-art performance at the time. Like with emotion detection, more recent technologies have led to better performance for sarcasm detection, but nowhere near as high as for polarity detection, reflecting again the difficulty of modeling such a subtle phenomenon as sarcasm. The next case study is about state-backed propaganda. In this research, we focused on polarity and objectivity in the language used in the propaganda content. The context for this research is that many people are obtaining their news from social media rather than official channels, and this is even more so for younger people. We know from previous research that there are actors who coordinate propaganda campaigns on social media. And perhaps the best known example is Russia's interference in the 2016 US presidential election. For this research, the data was released by Twitter, now known as X, after the accounts were identified as state-backed. The data that was released was for several countries, and we focused on Iran. And more specifically, we narrowed it down to a particular political event, which is the Iranian nuclear deal. We found that there was an almost equal distribution of positive and negative tweets, which was unusual because in previous research, it has been shown that propaganda content was dominated by negative posts. So this indicated a change in strategy in how propaganda was being conducted. We looked into the objectivity of the language used in these tweets, and we found something very interesting, as shown in the violin plot on the slide. What we can see in this plot is that although the neutral tweets have the highest objectivity, as expected, many of the positive and negative tweets have a high level of objectivity as well. So this shows that objective language is used as a persuasive tool. The last case study is about emotion detection from videos. The previous case studies focused on textual data. This one focuses on videos because this form of media has increased in popularity and also has practical applications. The context for this research is that, given what we know about the roles of emotions, their automatic detection has potential applications in a variety of areas such as social robots, personal assistants, and educational technologies. For this research, we combined two datasets and we used Ekman's list of emotions, the list of 6 universal emotions. You can see the data distribution according to the emotions on the slide. So what we did was to combine 4 types of data into a multimodal approach. So all of these 4 streams of data were extracted from a single video. The 4 data types we used are text, audio signals, image, and motion. Each of them were separately modeled with state-of-the-art approaches, and the results were combined in a single output by using a weighted average. The results show that our multimodal approach shows an almost 3% improvement on the state-of-the-art multimodal approaches. We also compared our results, our multimodal approach, with results for each individual modality. So you can see the results in the table on the slide. I will pick one example, and this is for text, as we have looked at previous case studies using text only. And we can see that the results show that we have an improvement on previous results. So we have detection in the 80% sort of range, but it is still not to the level of performance of polarity detection. So we know that emotion recognition is still a difficult problem, even with the improvements and using the state-of-the-art technologies. As we've seen in the case studies, with some phenomena, such as polarity and emotions, we can obtain reasonably good results, or even very good results with polarity. For other phenomena, such as sarcasm, the algorithm's performance is too low to be used in practice. One of the factors influencing this performance is the labeling process. So to be able to train algorithms to detect certain things, we need examples of those things. So if I want to detect polarity, I need examples of positive, negative, and neutral data. In other words, we need the ground truth. We need something to measure against. Now, with subjective phenomena, this is very difficult to establish, especially if we want to be 100% certain. It's not something that we can measure objectively like we would measure something like height or weight. It is a subjective phenomena, therefore, by definition, there isn't an objective way to measure it. So what do we do in these situations when we want to model subjective phenomena? Well, we have two approaches for obtaining these labels that represent the ground truth. We ask people to provide them, or we use automatic or semi-automatic tools. Now, now I will analyze two case studies and the different approaches we took for this labeling process. In the learning context case study, the data was labeled by humans. There were 3 annotators that labeled the data independently, and their inter-rater agreement was 80%. For the 20% of the cases where they did not agree, the procedure was that they got together and discussed their opinions about these labels and then agreed a final label. Now, human annotator agreement seems to vary between 70 and 80%, and 75% is often used as the benchmark. Now, this is typical for 2 to 3 categories. When we're talking about more categories, like we would in the case of emotions, this problem becomes harder. So the more categories there are, the harder it is for the annotators to agree. For the case study on state-backed propaganda, we used a semi-automatic approach for labeling, and for this purpose, we employed the CentiWordNet lexicon. This is like a dictionary that has weights or numerical values for positivity, negativity, and objectivity for each word or term. So, for example, if we want to identify how objective a post is, we take the average values for all the words in that post. This approach is quite popular, but it has several shortcomings. So one of the problems that we might encounter is that words are actually missing from the lexicon. So the calculation will not include those words that the lexicon does not contain. A second problem that we might encounter is that the pre-processing of the text before calculating the scores may lead to removal of words that are actually relevant. So the typical approach is to remove frequent words, also known as stop words. And this removal is based on lists. And these lists sometimes contain negation words such as not and never. These words, however, are very important to detect negative polarity. So if these are being removed, it might even lead to a change in the actual polarity of the text. Finally, the third problem we have in this area is the way we actually calculate that a label is neutral. So the idea of the neutral label is that it is expressing objectivity. And that could be interpreted as a lack of subjectivity, so nothing positive and nothing negative. However, in reality, the way we calculate this is that we assign a neutral label when we have equal scores for positive and negative polarity, which is not exactly the same sense of objectivity as in lack of anything positive or negative. We just have a balance between the two. While technology seems to advance at a fast pace, the underlying data and theory may not reflect our current knowledge. And while we are aware of biases and stereotypes, these are largely ignored when we are developing new technology. For example, language evolves, but our tools, such as lexicons, are not updated at the same pace. So new words that come into language take a long time to make it into the lexicons with their numerical values assigned according to the different metrics used. Also, theory in other disciplines evolves, but we still use old theories. For example, most research modeling emotions, including mine, use theories from the 1980s and 90s about universal emotions. Now, these theories have been superseded by others, but these new theories are very difficult to frame in a way that allows computational modeling. Therefore, we are using out-of-date theories because the alternative is to not have them at all. Finally, we are aware of biases and stereotypes. So there's been a lot of research in this area, and we are becoming aware that they exist. And still the practice is to largely ignore these when we build new technologies. So, for example, we know that the technology behind ChatGPT and similar large language modeling tools have trained on data that is mainly in English and that reflects an American culture. So this is very specifically American, not Western, which would cover a much broader culture across several countries. But the research has shown that these technologies are very specifically American due to the data that was used to train them. In this presentation, I focused on modeling subjective phenomena such as polarity and emotions. This is an area that is of interest as we know that subjective phenomena influence human decisions and behavior. So we definitely want to understand it better. We want to know how to use it to help rather than to hinder. We are currently developing interactive technologies for many applications, and these would benefit from recognizing subjectivity and emotional states and adapting to them to make that interaction more useful, more helpful. There is, however, potential for exploiting such technologies. Therefore, there is a need for laws and regulations to prevent the misuse of these technologies. So this concludes my presentation. In this slide, I included the references related to the case studies that I talked about, so you can look them up if you are interested. I thank you for your attention, and I hope you enjoy the rest of the conference.